All right. Next up, we have Dr. Ebrahim Ahmadisharaf's presentation about mold growth, allergy, and asthma risk in residential buildings in the aftermath of hurricanes, which is very much on our minds. I know a lot of you who are joining us today have been personally affected in your communities by recent hurricanes in Florida. So I expect we're going to get a lot of good information today. Dr. Ahmadisharaf, welcome.
Yeah, well, thanks everyone for having me. This is going to be probably a different presentation than what we had today. I'm probably one of the few engineers here in the summit, but thanks a lot to the Florida Department of Health for the invitation. So, and also thanks for the introduction. So I'm going to talk about mold growth, respiratory health issues aftermath of large floods, such as hurricanes. In the residential buildings. And this is an ongoing research that we are doing. So it's going to be preliminary results, and we are still working to expand this. And I'm going to talk more, but we are looking for collaborations and in different aspects to extend this work. This was initially supported by the National Science Foundation under a rapid grant for Hurricane Ida. And then we took supplement funding for studying Hurricane Ian, which is ongoing. And this is in collaboration with Harvard School of Public Health, besides myself at Florida State University. With that, so just on the overview and significance of the war. So speaking of the natural hazards, flood events, we know that these could result in severe damages to the communities, economy, and environment. A lot of these are direct impacts, tangible, that we feel them right after the event. A lot of them are not felt right after the event, which are called indirect impacts. In general, talking about the flood communities, flood modeling and impact analysis, there's a poor understanding on the indirect impacts, such as those on the respiratory health issues as a result of excess moisture and dampness in the residential buildings. So example of what could happen during a rainfall flood event to a residential building, a house. So we have rainfall, water intrusion, and then flooding on the land surface that could make it way to the house, and then result in moisture that lead to mold growth and also respiratory health issues eventually. So although there is an understanding of this problem in general, there is a poor understanding of a range of factors. Comprehensive databases are missing in terms of different flood characteristics, human behavior, building properties, and how they basically affect the mold growth and respiratory health issues, especially we're focusing on allergy and asthma. And also the short, mid, and long-term impacts of flood events are poorly understood. Say what's going to happen like a few days after the event, and then also months and years after that, and how we could basically study those. So here we are looking into, say, the impacts, like I said, it's a preliminary result, like 2 months after the hurricane, and we are focusing on Hurricane Ida, happened in 2021, centered in New Orleans, Southeast United States, but made its way to the northeast, all the way, New York City, Philadelphia. They're also impacted, and with a less severe impact, of course. So sort of summary of what we did. So we started with recruiting volunteers for participating in our studies. And that included home inspections and also online surveys. And we took samples for laboratory experiments on the mold and air samples. And then we also did some flood modeling to basically characterize the flood variables, such as flood depth and other factors. And then we put all this together to do some relationship analysis to see what are the important variables affecting mold growth and also respiratory health issues in the residential buildings. So starting with the first part, which was recruiting volunteers, this was a huge task. It didn't seem that huge to us in the beginning, but we ended up having a lot of issues with like finding volunteers. We use a lot of approaches. We use social media. We've worked also with Louisiana State University's Cooperative Extension, various non-governmental organizations, NGOs, faith-based organization, also with the Louisiana Department of Health for finding participants for our study. And then once we did that, we did some online surveys, questionnaires, to get information on how were impacted by the Hurricane Ida. So a bit of our criteria. So basically, we wanted to focus on the population that were impacted by the hurricane. Different levels of impact shouldn't be necessarily like severe impacts. We also wanted to have some control samples in order to avoid unbiased results, whether to correlate something and attribute changes in asthma or mold to some flood characteristics as our control samples, basically. And we wanted to focus on our homeowners, and we also avoided houses with smoking members, again, to avoid unbiased results. And also we asked about the intervention during the event, and that basically was done through our preliminary survey. That was done through a online questionnaire. Then finding the volunteers after recruiting, we did some home inspections. This was done by our Harvard collaborators. So I don't take any credit for that, but so they went in the houses. They did inside inspections through application of different equipment, such as infrared camera, also visual mold and dampness assessment. And we also use blower dose tests to measure ventilation and taking different samples, air samples, surface samples. We sent this eventually to a lab for the measurements of different species of mold. Besides that, we also asked a lot of questions from the participants related to their interaction, so more comprehensive compared to our first question, like number of their attacks before and after the hurricane, and also any changes they made. So we call this comprehensive survey, basically, again, a more comprehensive online questionnaire. So this is the next step. We sent this to a lab, Eurofins, and they characterized more than 40 mold species. If any was detected, also total mold spores. And then we summarized these plus the comprehensive survey results, and then sent this to the families, homeowners that we inspected their houses. So this is going to be probably a boring part for the audience here. So we did some numerical modeling, flood modeling here, to basically identify what is the depth of flooding, maximum depth of flooding during the Hurricane Ida at the houses that we surveyed, because this information is not necessarily available. So different approaches that we use, and we are also using for our ongoing investigations. So there are existing models, such as the SERA model, Coastal Emergency Risk Assessment by Louisiana State University. So they provide this through computer models that we use. In addition to that, we also use some data-driven techniques, machine learning algorithms, and geography information system, GIS, that are informed by the underlying physical processes to characterize flood variables, such as water level. And then we run through our data against different sources, high water marks, extreme water levels, and also satellite imagery. And this is part of it was done for Hurricane Ida, but this is what we are doing basically for the current investigations for Hurricane Ian that I'm going to talk about later. So the model, example of what we used, a lot of variables were used to model flood variables, Hindcastle for the event, including the location, hydrology, meteorology, topography, land surface and subsurface properties, and also coastal factors such as storm type. So some results of our data-driven models, random forest. This was updated recently, so this is probably late May results that we had. Different techniques, random forest, and we look at the errors and also the correlations, such R-squared numbers, which we found a good correlation for predicting the flood variables. And also other techniques such as neural networks and XGBoost. We eventually used the best model, obviously, and then this was put inside with the surveys that we did, the lab results, all together made a unified database, which took us to the next step, which was now that's going to answer our question, like what are the important key variables for mold growth in the affected buildings and also for the asthma and allergy impacts. So we again, using that database, we used machine learning algorithms to identify the relationships between these factors. And this is sort of showing the factors that were used for, from the left, we see flood characteristics, residential building properties, and human behavior after the hurricane, during hurricane, for mold prediction, and also asthma and allergy. So it's showing the linkage, basically, what are the important variables. And then just to summarize that, in terms of mold, what we found was that the application, human action was very important, using air fresheners, the home repair time, and also maximum inundation depth, flood characteristic that played a role, and also other preventive measures, and also the home age. For the asthma on the right side, we found that the maximum inundation depth near the house was a critical variable, followed by smoking habits, days spent at home, and also other attitudes, plus the repair time, and also actions of the humans, such as preventive measures applied in the house, and also the presence of different mold species. So this has a lot of applications. Again, I want to emphasize that this is ongoing. We're looking to expand this, but what we are hoping to achieve down the line is basically guiding the design of the buildings and inform occupational health scientists for building indoor environments, especially residential, that are resilient to flood events. Especially, we see a lot of changes with the climate change, rising sea levels, precipitations, see more intense storms. So this is going to be even more critical compared to what we see in the past. So this is going to eventually develop a foundation for implementing quantitative models that assess that risk of different flood events, and also inform like public health officials, emergency responders, and insurance companies for their activities. We would like to work with outreach specialists also to inform local communities about the respiratory health issues, because education would play a significant role. And by education, which, as we saw, some of the actions would play an important role for allergy and asthma risk, as well as the mold in the buildings. So I want to also talk about the limitations of the study and also future steps. So the sample size used in this study was small, especially what I presented. It was 25 samples. And this was, again, like some pilot study that we are going to extend in the future, hopefully. And we looked at just basically a snapshot. How does it look like for you now in terms of like asthma attacks or mold in your house? But there are gradual impacts that we need to like do more extensive studies to better track what happened, that we see these changes in the human respiratory health and also the mold. Speaking of that, future steps, we already have done some other studies. I mentioned that Hurricane Ida made its way to the Northeast region. So we also did some samples and inspections there. And we also did some study for Hurricane Ian. We haven't got the relationship analysis yet, but we have the data now to basically do the similar analysis to see whether the results are also valid for these events, similar to what we found, or what differences we see, or do we need new models. As I said, recruiting volunteers and making sure that we have a diverse sample is very important. So we are actively looking for collaborations, especially collaborations with community engagement expertise. So that's something that I would like to have some conversation if there is an interest on that. One other thing I wanted to emphasize was that the analysis was done based on surveys, so basically questions through questionnaire from the houses, the families that we inspected, but we didn't do any medical tests. So it was basically just questions. That's another limitation that through future collaborations, if resources are available, we could address. And this was only focusing on major floods as a result of hurricanes. What we strongly believe is that the range of flood events could play a role in affecting our human respiratory health issues. One reason for that would be that people might not even care about the small events. That could be a small water intrusion similar to hurricane events. These are some pictures of our ongoing work for Hurricane Ian that our Harvard collaborators did in South Florida, Fort Myers, Orlando. And then just to summarize and wrap it up, so we basically looked into the relationships among flood characteristics, mold growth, allergy and asthma risk, and also human actions in the affected buildings post-hurricanes. The case study I presented was Hurricane Ida. So we collected data, recruited volunteers, did some online surveys, home inspections, lab tests, and modeling, machine learning analysis in order to investigate the relationships between these factors. And we found that basically what are the key variables in terms of allergy and asthma and also mold growth in the residential buildings. Just to acknowledge, again, National Science Foundation for the support, the funding for this project, and also Louisiana Department of Health for helping us with finding volunteers and all the volunteer participants who basically took time and participated in our study, and all the team members. Unfortunately, not all of them are here, but my PhD student is here, Mariam, who is also doing the relationship analysis for the Hurricane Ian. With that, I'm gonna stop there, and I look forward to have some discussions, either if you have time now or later.
Yeah, you still have time. So any questions from
And thanks again.
Dr. Garcia?
So some of the differences between like the small floods and the hurricane floods, do you have any preliminary?
We don't, but what I wanted to mention was that it could be a small rainfall event that results in water intrusion, and then people might not even care about like whether there's a presence of mold in the home, right? Compared to a hurricane event. But yeah, I can't say, we don't have preliminary results. We had this conversation with CDC also, the environmental health, and then they also certified that from their investigations, there was no quantitative analysis, but what they also said was that one of the things that people don't care much overall about small events, that could be a serious issue, which is unfortunately ignored. And it's not even considered a flood event.
Have you guys partnered with any like organizations? Because there's some in that we were partners with the Tampa Bay Asthma Coalition that would kind of come in if a home was identified with triggers that were known to exacerbate asthma. And so have you guys looked at that anywhere up in Tallahassee?
That's a great point. We have not, but that's something that we are actively looking. And this type of grant was for certain event, Hurricane Ida, and then extended to Hurricane Ida, and then extended to Hurricane Ian. These two are very similar. I always like mix them up. But then we are looking for like doing some more generic, like basic research. But yeah, definitely, I would like to have more conversations with you to identify those organizations, because that's something that we need. Yeah. Thank you. Yeah.
Is air quality, like an air quality test, adequate to figure out if there's mold in the building, or do you need more testing?
The short answer is that I don't know. I wish that's a question for my collaborators at Harvard, who are public health scientists. I think for our preliminary results, we found that sufficient. But we should look into probably more sophisticated or more extensive analysis for the larger projects. Thank you.